Amidst the hustle and bustle of everyday Newport news sits a nondescript set of buildings that seem innocent enough. But 25 feet below the surface of the earth, this facility is slamming things together at speeds hard to imagine. A very simple explanation for some of the most cutting-edge science in the world.
The beauty of this kind of science is, for each answer that you get, chances are quite good that two new questions were posed. And so it's a never-ending, fun job.
Jefferson Laboratories houses an accelerator that shoots a beam of electrons no bigger than a human hair around a track and into a target, trying to break apart a nucleus into quarks, the smallest particles known to man. Still with me?
We're finally at the point now where we can start to understand how these quarks are interacting with each other. But what we aren't quite yet sure about is the forces that are holding these quarks together and exactly why that functions the way that it does.
Quark pairs have never successfully been separated, but a new $75 million grant from the government will give these physicists double the power to see what makes quarks tick.
I'd describe it as creating the future.
By 2015, 10 more new and improved cryo modules like these will be added to the track, doubling the energy of the electron beam and increasing twofold what this massive microscope can see. Imagine this 450-ton collection of equipment that I'm standing on is a giant catcher's mitt that rotates around this hall to detect the smallest particles known to man and hopefully give us a better understanding of what we and everything else are made of. And this is just one of what will be 4 halls that can conduct experiments simultaneously. The project is costly, $310 million tax dollars in all, but the upgrade is already creating millions of dollars in local construction contracts and leading to discoveries that researchers never intended.
When I found the lump, needless to say, I was pretty anxiety-stricken.
That view and that view are the same.
Like so many women, Wendy Condor was devastated when her doctor diagnosed her with a mass in her breast. She had gone through 2 surgeries already when she found a lump for a 3rd time.
It's exhausting, it really is. Lots of lost sleep.
But the same technology that allows scientists to detect subatomic particles at J-Lab led to the Dylan 6800, a gamma-ray imager that is dramatically more detailed and less uncomfortable than a mammogram.
It allows us to see what's actually going on, what's the molecular biology that's going on, and from that we can determine very specifically that there is something that warrants consideration.
I went from your whole right breast is abnormal to you're good to go.
On numerous occasions had women write and just explain that literally they think that we've saved their lives.
Dylan and the other practical applications to its technologies are a source of pride for all who work at J-Lab. But for them, the search for knowledge alone is enough to keep them going.
No, it's fascinating. I love it.
It has the potential to truly be a discovery in the world of physics and either help us add to the standard model of physics or perhaps point out some flaw in the thinking that would need further explanation. And of course, either one of those is an exciting result for a scientist.
You may not have known what was going on at J-Labs, but chances are your kids do. Middle school students in the Beams Outreach program actually take classes and conduct experiments there. And since none of the work at J-Lab is classified, the scientists encourage tours and visitors. They say they're so excited about the work being done there, they usually have to be told to stop talking about it. Now, if you'd like to learn more, we have linked the J-Lab website to WTKR.com. Just click on the As Seen on News Channel 3 section. Pat McReynolds, News Channel 3.